Before we go directly to data structures and algorithm, let me give you a little background about programming language. Because basically, data structures and algorithms, we must familiarize at least one programming language. Okay, but what is a programming language? So programming language is a software application that we use to write computer programs. And there are two types of programming language. So we have what we call the low level and the high level. So the low level programming language, typically this is a difficult language to learn and it is very far from human language. But despite of the fact that it is very far from the human language, it has a fast execution. But it is hard to modify. Once you write your instruction using low level language, expect that you will have this difficulty in modifying your instruction because these instructions are all dependent in your hardware because they are used to write hardware programs. Example of this are machine language and assembly. Now for high level programming language, this language is easier to learn compared to low level because it is very near to human language. However, it has a slow execution time. But despite of that, it is easier to modify your instruction. Whenever you write codes in high level language and when you want to modify this later, it will be easier compared to low level language. And high level language are used to write software application. So what are examples of high level language? Examples are Python, C Sharp, VB.NET. Human language, example, in English, how are you? What do you do? But when we say high level programming language, these are instructions that displays or execute your codes. In the example you have there, the console that write line hello. So what will happen to this is that it will display a hello text on your screen. Okay. So it is almost like an English language because you know what is a console, you know what is a write line, meaning when we say write, you write, you write a line. For low level, example is move EAX, add EAX, BX. Basically, these are the codes usually used whenever you assign value to a register. And when we say register, these are all dependent to a hardware. And then lastly, when we say machine language, these are zeros and ones. And this is the language that our computer can understand. So if you write a software application or a computer program wherein this is the language that you will use, 0, 1, 0, you will have a terrible hard time on figuring out what does this thing means. So that is why we have this high level language so that it will be easier for us to write software application. So for example, you have A. The binary code equivalent for A is this code here. Let's say for example, this letter A in our computer has an equivalent binary codes assigned to it because letter A basically does not mean anything to our computer because it cannot understand what is A. However, for us to be able to understand what is A, it has to translate this binary code equivalent to this letter A. So whenever our computer reads this value, it interprets that value and shows up this character so that it would have a meaning for those user like us because normally we don't know what the value of this binary codes is. Okay? So same thing with letter B, capital letter B. And that's also the same scenario for our small letter alphabets. If you want to see more about binary codes, the equivalent binary codes of each character you have on your computer, you can see that in convertbinary.com or you may also use binarytranslator.com. So let's give this a try. So this is the convertbinary.com. So this is the list of binary codes for each letter. You can also visit the binarytranslator.com. So in this page, just type in a letter here and then it will display the corresponding value of that letter into binary codes. Let's say letter V, or let's say any letters that you want. It will display the binary codes of that letter.